Intro. Welcome back to our channel. Today, we're diving into an exciting and increasingly vital topic in the field of artificial intelligence: building a production-ready AI workflow. Whether you're a seasoned data scientist, an aspiring machine learning engineer, or just someone curious about AI, understanding how to build an efficient workflow from data ingestion all the way to model deployment is crucial. We'll also discuss how to integrate continuous integration and continuous deployment, or CI/CD, into this workflow to ensure that your AI models are not only effective but also maintainable and scalable. So, grab a cup of coffee, and let's get started. Section 1: Understanding AI Workflows. Before we start building our workflow, let's clarify what we mean by an AI workflow. An AI workflow is a series of steps that data goes through from the moment it is collected to the moment it generates insights through a deployed model. The key stages usually include data ingestion, data preprocessing, model training, evaluation, deployment, and monitoring. Each of these stages is essential for creating a robust AI solution that can handle real-world challenges and adapt to changing conditions. Section 2: Data Ingestion. The first step, data ingestion, is where everything begins. Data ingestion is the process of collecting and importing data for further processing and analysis. This data can come from various sources, such as databases, APIs, third-party services, or even real-time streams from IoT devices. In a production-ready workflow, you should consider how this data will be ingested continuously and reliably. To set up data ingestion effectively, using tools like Apache Kafka for real-time data streams or Apache NiFi for data routing, transformation, and system integration can be highly beneficial. They allow you to automate data flows and ensure that the data is available when needed. Additionally, it's essential to think about data quality at this stage. Implementing validation checks and cleansing processes as data enters your system will save you significant headaches later on. A good practice is to set up data profiling to understand the data structure and spot any anomalies or missing values early in the process. Section 3: Data Preprocessing. Once your data is ingested, the next stage is data preprocessing. This step is vital because the quality of your input data directly affects the performance of your AI models. Data preprocessing includes cleaning the data, handling missing values, encoding categorical variables, and normalizing or standardizing numerical features. Data cleaning involves removing duplicates, correcting inconsistencies, and managing outliers. Tools like Pandas and Python are widely used for these tasks. If you're working with larger datasets, consider using Dask, which is designed for parallel computing and can handle larger-than-memory datasets efficiently. Handling missing values is another crucial aspect. You can choose to fill them with statistical measures, like the mean or median, or consider more advanced methods, such as k-nearest neighbors imputation. Once you've cleaned your data, you'll want to encode categorical variables into a numerical format that can be understood by machine learning models. Libraries like scikit-learn offer simple solutions for this task. Finally, scaling or normalizing your data ensures that features contribute equally to the model's performance. Techniques like min-max scaling or standardization can help achieve this. Section 4: Model Training. With your data preprocessed, the next step is model training. This is where your data science skills come into play. Depending on the type of problem you are trying to solve, classification, regression, clustering, etc., you will choose the appropriate algorithms. You also need to consider the configuration of your model. Hyperparameter tuning is critical for optimizing your model's performance. Techniques like grid search or random search can help you find the best parameters. Moreover, using libraries like TensorFlow or PyTorch will give you the flexibility and power to build complex models, such as deep learning architectures if needed. It's also essential to split your dataset into training, validation, and test sets to ensure your model is not overfitting. Techniques like k-fold cross-validation can provide better estimates of model performance by utilizing different subsets of the data for training and validation. Don't forget to track your experiments. Tools like MLflow or weights and biases allow you to log parameters, metrics, and model artifacts, making it easier for you to compare results across different experiments. Section 5: Model Evaluation. Once the model is trained, you need to evaluate its performance. This step is crucial for understanding how well your model will perform in a production environment. Various metrics can be used depending on the type of task. For classification problems, metrics like accuracy, precision, recall, and F1 score are commonly employed. For regression tasks, metrics such as mean absolute error or R-squared are more appropriate. Evaluate your model on the test set that was kept separate from the training and validation sets. This will give you an unbiased look at how your model performs on unseen data. If the performance is not satisfactory, you may need to go back, tweak your model, or even revisit your data pre-processing steps. Visualizing your model's performance using confusion matrices or ROC curves can provide deeper insights into where it may be falling short and help you identify areas for improvement. Section 6, Model Deployment. Now that we have a trained and validated model, it's time to deploy it into production. Model deployment is the process of making the model available to users or other systems to generate predictions. There are several deployment strategies, including batch processing, real-time inference, and embedded models. For batch processing, you might set up a pipeline that periodically runs predictions on a scheduled basis. On the other hand, if your application requires real-time predictions, you may want to deploy your model as an API using frameworks like Flask or FastAPI. These APIs can serve predictions to client applications almost instantaneously. Containerization technologies such as Docker can be incredibly useful for ensuring that your model runs consistently across different environments. By packaging your model and its dependencies into a Docker container, you can avoid compatibility issues that arise when deploying in various settings. Kubernetes can be used to orchestrate your containers, providing scalability and resilience. This way, if your model experiences heavy traffic, Kubernetes can automatically scale the number of replicas to handle the load. Section 7, CI/CD integration. Now that we have our model deployed, it's essential to ensure that updates and changes can be made smoothly. This is where CI/CD, or continuous integration and continuous deployment, comes into play. CI/CD is a set of practices that automate the processes of software development, testing, and deployment. In the context of AI workflows, CI/CD ensures that changes to your models can be integrated and deployed seamlessly without disrupting the production environment. Start by setting up a CI pipeline that automatically tests your code and model whenever changes are made. Tools like Jenkins, GitHub Actions, or GitLab CI can help automate these tests. You should focus on unit tests for your code and integration tests that verify that your model interacts properly with other components of your system. Once your tests pass, you can set up a CD pipeline that will automatically deploy your updated model to production. This can involve retraining your model on new data, validating the new model's performance, and then deploying it if the new model meets your criteria. Implementing CI/CD in your AI workflow not only makes the deployment process faster but also enhances your model's reliability. You can roll back to previous versions seamlessly if something goes wrong with the new deployment. Section 8, Monitoring and Maintenance. Finally, once your model is in production, the work doesn't stop there. Continuous monitoring is crucial to ensure that your model maintains its performance over time. Real-world data can shift, leading to what's known as model drift. This occurs when the statistical properties of the target variable change, leading to a decline in the model's predictive performance. Implementing monitoring tools that track model performance metrics in real time can help you quickly identify when your model starts to degrade. Solutions like Prometheus for monitoring and Grafana for visualization can be incredibly helpful in this regard. When you detect performance issues, you may need to retrain your model on new data or make adjustments to your pre-processing steps. Always ensure that you have a strategy for model retraining and redeployment. Conclusion. In conclusion, building a production-ready AI workflow involves several key steps: data ingestion, data pre-processing, model training, evaluation, deployment, and integration with CI/CD practices. Each step is critical in creating a robust system that can handle the complexities of real-world applications. Remember that the journey doesn't end with deployment. Continuous monitoring and maintenance are essential to ensure that your model remains relevant and effective. By following these guidelines, you can set yourself up for success in the rapidly evolving world of AI. Thank you for watching. If you found this video insightful, please give it a thumbs up, subscribe for more content, and share your thoughts or questions in the comments below. Until next time, keep keep exploring the fascinating world of AI.